Okay, so have you ever stopped to think about just the sheer power needed for everything we do online now? Simple searches, streaming shows, even those AI images popping up everywhere. It all runs on this like hidden network of servers, massive ones. And the kicker, they're incredibly power hungry, seriously.
Mm.
Some projections say that by 2030, data centers could eat up, what, maybe 8% of all global electricity? That's huge.
Yep.
So, if that's the scale of the problem, what if there's a really different solution, maybe even a natural one?
You've really nailed the core issue there. And it's critical to understand that, well, the biggest energy hog isn't just running the computers themselves, it's keeping them cool. Servers throw off immense amounts of heat, right?
Right.
And if you don't cool them effectively, they just they fail more often. So managing that heat, it's a massive energy drain, a huge bottleneck. It really is the silent killer of efficiency, as they say in the data world.
Right. And this is where things get really interesting for this deep dive, because looking through the sources you sent over, one potential solution just jumped out. It sounds almost like science fiction. The ocean.
Yeah, imagine the sea itself. It's naturally cold, especially deep down and very stable temperature-wise. It could be this, well, almost perfect, elegant cooling system. And it's not just theory anymore. We're going to explore how the cold deep sea might actually become the kind of the beating heart for the future of AI. Now, to show this isn't just talk, let's look at Microsoft. They did this pretty bold experiment back in 2018, Project Netick, they called it. Kind of secretive at the time. What they did was they basically sank a data center 117 feet down off the coast of the Orkney Islands in Scotland. Picture this, like a big sealed tube, maybe the size of a shipping container,
Yeah.
packed with 864 servers. And it was powered entirely by local renewable energy, wind and solar, I think. And cooled, obviously, just by the seawater around it.
Oh.
Sounds wild, doesn't it? Oh, it was incredibly daring. Definitely pushed the boundaries. The basic idea, the hypothesis, was pretty straightforward, though. Could putting servers underwater in a sealed unit drastically cut those cooling costs? That was number one. And maybe, just maybe, also make them more reliable by protecting them from, the usual environment. Dust, oxygen, people bumping into things. It was a big bet, for sure. But the potential payoff was huge if it worked.
So the million-dollar question then, did it work? What did they actually find after running it for 2 years down there? Because the results highlighted in the sources seemed, well, pretty amazing. Did it live up to the hype?
It absolutely delivered, and perhaps even more than they expected. What's really fascinating here is how Natick challenges our old ideas about data center environments. Over the 2 years, they saw way fewer server failures.
Yeah.
Something like 1/8 the failure rate of a land-based center.
Wow, 1/8.
Yeah. And the internal temperature was remarkably stable. Plus, it ran on 100% clean energy, which is a huge win. But here's the really interesting part, the unexpected bonus. The sealed environment itself was key. No oxygen, very low humidity, no dust, and crucially, no humans messing around.
Right, no clumsy technicians.
Exactly. It created this perfect, pristine, super stable operating condition. So it wasn't just about saving energy on cooling. It actually made the servers last longer and run better, like a silent, protected server vault under the sea, completely removed from the usual chaos.
That is quite something. So the environment itself became a feature, not just the cooling. Okay, with results like that, it's really no surprise that other companies are jumping on this, right? We're seeing names like NVIDIA, Oracle. They're apparently exploring scaling this up. The sources talk about AI farms submerged offshore. Can you picture that? Like the world's most powerful AI models, the ones writing code or generating images, just humming away silently under the waves. What does that mean for the bigger picture if we connect those dots?
Well, if we connect this to the bigger picture, the potential is genuinely transformative. Think about it. Large-scale underwater computing. You could completely change data infrastructure. You could place massive computing power right offshore, closer to big coastal cities where demand is high.
Reducing latency, maybe?
Exactly. And drastically cutting the carbon footprint. No need for those huge, power-hungry air conditioning plants on land. It's not just about making things more efficient. It's potentially reshaping the actual physical layout of the internet, making it more resilient, more sustainable.
That's a really compelling vision. A greener, maybe even faster internet. But okay, like with any big tech shift, the sources also raise some red flags, some critical questions. What about the downsides? What are the ethical issues or control issues here? Could these underwater data centers become like dark zones, hidden places for computation we don't know about, maybe even surveillance.
Mm.
And, what happens if a handful of big tech companies start essentially owning or controlling huge patches of the seabed for their private servers? That raises questions, doesn't it?
Those are absolutely valid points about transparency, governance, and control. And they feed into a much larger dynamic. Because this isn't just happening in the U.S. or with U.S. companies. Far from it. What's really striking when you look globally is the race that's underway. China, Japan, several Scandinavian countries, they're all actively developing their own underwater computing capabilities. Very actively.
Ah, so it's competitive.
Highly competitive.
Right.
When the sources mention a new Cold War fought in the ocean depths, it's not just a dramatic effect, it's a strategic race. Who controls this foundational infrastructure for the AI future? It's about data sovereignty. It's about economic advantage. It's about national security. It really is a new frontier opening up, being contested in, well, the coldest, deepest parts of our planet.
So if we boil it down, the main takeaway from this deep dive seems to be AI isn't just living in the cloud anymore, it's heading into the current, literally. The next big wave of innovation might just be underwater.
That sums it up well. The future of AI, or at least a significant part of it, could very well depend on how deep we're willing to go. Not just deep into the data, but physically deep into the ocean, to find sustainable ways to power all this intelligence.
And that leaves us with something to think about, doesn't it? As automation and AI keep expanding and we push technology into these completely new, unexplored places, literally the deep sea, what are the ultimate trade-offs? What are our responsibilities that come with venturing into these depths, both, physically and metaphorically? Definitely something for you to mull over until our next deep dive.